Okay, so I was just asked a very important question. What is the most important part of agriculture? Now, this is such a huge question. I mean, agriculture is what feeds us, it gives us clothing, it gives us houses. Without agriculture, we are starving, naked, and homeless. Like, it's such a big industry. But what is the most important piece of agriculture? So, I decided that I'm just gonna try to start drawing pieces of agriculture and seeing if I can figure it out. So we're gonna start, let's start with an animal. Any animal, maybe hamburger. What makes hamburger? A beef steer. So we're gonna start with a cow. So I'm really bad at drawing, but you get the idea. So we've got, and so it's a cow, it's gonna go moo. Okay, so we've got a cow. And then, what does a cow eat? Because to make a cow, you have to have the food that it eats. Well, it eats a lot of plants. So it eats like grass and corn. So it eats grass and it eats corn. Okay, and what does grass and corn need? I don't have a yellow marker, but I have an orange marker. They need the sun, because we covered in Bill Nye that plants need three things to grow. They need sun. They need carbon dioxide. What was the third thing? Most plants need soil. These are all grown in soil. I don't have a black marker, but we're gonna pretend that's brown. So they need soil. And even forestry, where we're growing trees, these trees, they grow in soil. And natural resources, we pull those resources usually out of soil. So really, the base of all things agriculture come from soil. But a lot of times when we talk about soil, it's dirty. What's so special about a handful of dirt? Well, there's a lot of things special about a handful of dirt. First of all, it's not dirt, it's soil. In agriculture class, we never use the word dirt. Dirt is the junk you drag in on your shoes. Soil is alive. In fact, in a teaspoon of soil, there are over 1 billion organisms. In this handful of soil, there are probably more organisms than there are people in this world, which is insane. Soil is alive. Soil is necessary for human life. We owe our entire existence to about an inch of topsoil and the fact it rains. So the first thing we're going to be kind of diving into in the world of agriculture is soil. So let's kind of start with that. What is soil? Well, I've got a cup of soil right here. I'm going to add some water to it, make it a little muddy, and I'm going to play with it. Oof. And, okay, the soil, let's try to use a lot of our senses. First, let's smell it. Ooh, it smells kind of like Home Depot. Probably because this is bought soil. So the fact that we buy soil when you can step outside and just, dig up soil. There must be something special about this soil. And there is, which is why we pay for it. Now, if I look at the soil as I feel it, it really crumbles apart. Even though it's wet, it crumbles quite a bit. And I can stick it together, make it into a clump. But as soon as I pick it up, it kind of falls apart. So it looks really dark in color. It smells kind of like Home Depot. And when I feel it, when it's wet like this, yeah, there's some gritty things, but it kind of feels like flour. I wonder if all soil feels that way. Follow me and we're gonna find out. All right, so I decided the first place we should check is right outside our door. So I grabbed some mud from right over there, and you know, this feels different than the soil we touched earlier too. The first thing, if I smell it, it smells a lot more like gravel, but that's probably just because it's right next to a gravel road. But the big thing is when I squish it, it forms a ball really easily, and it's a lot darker. And when I really squish it, it extends, doesn't crumble at all, or almost at all anyway. And it kind of feels like the clay in Mr. Z's class. Interesting. Let's check out one more place. So, we just landed at the beach at Moose Lake. And it's not a very good beach, but it'll work for our purposes. So, at the beach, we have a special type of soil. And you might make something like sand castles out of it because it sometimes sticks together, but not super well. Only if we have a lot of water. So, if I feel it, first let's smell it. What does it smell like? Ah, decaying aquatic plant matter. Kind of smells like lake, which makes sense because we're at a lake. And then when I look at it, it's kind of a light-ish color. Not as dark as some of the soils we've seen. And when I feel it, it's super gritty. So why does this soil feel different than the other soils we've looked at? Well, let's hop back to the classroom and find out. All right, so we went outside and we played with some soil. It was squishy, it stuck together really well. Then we went to the beach and we played with some different soil. It was super gritty, it fell apart really easily. But why did different soils act differently? Well, there's a lot of reasons. In fact, soil is so complicated that you can have your entire college major in soil science. In fact, you can get a doctorate in soil science, and there's a demand for it. These doctors in soil science get jobs, which is insane. So obviously, as a 7th grader, I don't expect you to fully be able to grasp every characteristic of soil. But one of the big differences in the soils we tested was particle size. And there's kind of 3 types of particle size. First one, really, really, really tiny. And we call that smallest one clay. And clay is really, really small, and it feels a lot like the clay you play with in art class. It's squishy. When you squeeze it, it doesn't break apart. You can form it into things. And in fact, clay you get in art class is actually a type of soil. Now, bigger than clay, we have silt. And silt is more similar. Clay is more like the soil out on the practice field. Silt is more like the soil that we got from Home Depot. And now this is a mixture of a lot of different types of soil. There's some clay in it, and there's some of our third option. But it's more powdery, and it doesn't stick together quite as much as clay does. Lastly, our biggest particle size is sand. Now, clay is less than, remember that's the less than sign, 0.002 millimeters in diameter. It's so tiny, you need a microscope to see. Silt is between the 0.002 millimeters and 0.05 millimeters. Sand can get as big, oops, that shouldn't be meters, it should be millimeters, can get as big as 2 millimeters. Anything bigger than 2 millimeters is considered a rock. So silt is between this 0.002 and that 0.05 millimeters. Now, those numbers are so small, they're hard to conceptualize. Because clay is so small, you need a microscope. And sand, every time we go to the beach, we can see sand. And silt is in between. But just to put a comparison on that size, I have a jar of marbles. This marble here, we're going to say this is the size of clay. Now, in real life, clay is a lot smaller, but we're going to pretend that this is how big clay is. A golf ball, or this duck that's about the size of a golf ball, is the same size as silt. So clay, silt. Then, sand can be as big as this. There's that much of a difference in size. So, we have such a wide variety in size, it makes sense why different soils would behave differently. But that brings us to the question, why do we care? Well, again, you can get a doctorate in soil science. And for this brief unit, we're not trying to get a doctorate. We're just playing around. So, if you have a bunch of tiny dots smushed close together, as clay would be, there's not a lot of space. These marbles, when you put them in a big thing like this, marbles are big. You can get water between them, but not as much as if you had a bunch of ducks. And if you had a giant thing full of beach balls, well, now water can pour through really easily. So one of the biggest things is a word we call drainage. Last fall, when I first showed up here, if I walked across the practice football field, I'd be like ankle deep in water. It's because there's a lot of clay. The water would just sit on top. It couldn't get through the surface. However, when I go to the lake, that soil was a lot more sandy. So when the water would come up, it would fall through the cracks and keep going in. Silt is somewhere in between that. So that's one of the biggest reasons we care about particle sizes. Now, there are very, 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 very few, I'm not going to say none, but very few soils that are 100% clay, 100% silt, or 100% sand. But it's what percent of each one of those things that makes up the characteristics of soil. So, in this video, we got to see a few different types of soil. We got to observe those soils, and we learned about the 3 particle sizes: clay, silt, sand. Clay is the smallest, sand is the biggest. What I want you to do now is in Schoology, there is a worksheet for you to do. I want you to go in your own backyard, find some soil. I want you to smell it. I want you to look at it. What color is it? And I want you to feel it. So I'm trying to remember what all my senses are. So smell, look, feel. Then I want you to record those observations. Notice when I was describing how this looked or felt, I never said it looks like soil or it looks like dirt. I said it feels like flour, or it's really dark in color compared to our sand that was really light in color. When I smelled it, I said it smelled like Home Depot. I didn't say it smells like dirt. I don't want you, first of all, to ever use the word dirt, but second of all, I want you to try to find other words to describe what it looks, smells, and feels like. I hope you have a super fantabulous day and have fun checking out some soil. See you later.